All right. So we're back, and in this case, we're going to be working on 3D printing. So as we're all seeing that we have our model right here, uh, how do we actually be able to 3D print this model? So the first things we have to do is actually set up a new Rhino. So one of the important things I've told you guys is what do you check for once you open a new file? The units. So right now, before I actually choose what file I want, I can actually sub-choose it to millimeters. But if you didn't do that, let me minimize both of these. You can change the units. So always make sure you're on the correct units. For now, you guys should be on inches. You can tell by seeing my cursor right here, it says inches. But if you're not sure, type in units in the command line. A new window will pop up. Of course, model units, inches. For your model. Of course, you can change the distance displayed to feet in inches, and I typically do mine to 1/32 or 1/16. It's up to you to choose for that. Of course, the layouts are right here. Sometimes when actually when you make a new file, the layouts are in millimeters for some reason. If it is, you can just check your units right now and change it back to inches or feet. But typically layouts, it's best to put them on inches because they're going to be your real life paper size, 8.5 by 11 for letter, Arc C for 18 by 24, and Arc E, etc., etc. But like I say, in inches, make sure it's on inches. Inches for you on your actual main one. But by now, it should be on inches, hopefully. If it's on millimeters, you can change it to inches itself. So now that you have a new Rhino file, I typically Control S to save it, and I save it along my computer so you can get. You can see right here, I've done it before. I'm just going to name it 3D print millimeters for now. 3D print millimeters class, just so I know the differentiation. So I have our saved new file. So now we have our millimeter file. I'll explain in a bit why we actually need that, but one of the more important things is learning how to scale. Let me find a file because one of the main challenges is learning how to scale. Let me see if I can find one within my computer. Boom, school files. Let's do, because in the future you're going to be working in feet and it's different. It's scaling it in feet is different than scaling it in inches. Um, and I'll show you how to do it in feet. So the house project, studio, Nate, project 2. Yeah, let's do this house. This is not the final. Let's be which one's more recent? Let's do this one. Oof. Okay. So this is what a project would typically look like when you're working in advanced. You have so many layers. It's always good. I'm not an organized person, so that's why I tell you guys do as I say, not as I do, to organize your files before it gets chaotic as mine. But as you can see on the bottom left, you can see where my mouse is. It says feet. So once you're working at this scale, if I do measure something, it is going to be, of course, 4'6". It's going to be in feet. So how do I turn this into a model scale and printable scale? So let's say I've done this before with this model. I want to print out these two objects. Whoops. I just accidentally alt tab back to one of those. So, okay, now that I'm back on this, so I just copy this off to the side. How do I make this 3D printable? So one of the main factors is knowing at what scale you want to print out your model. So since this is in feet, at what scale do I want to print it at? That is determined by your professor. So if your professor says the final model will be at 1/4 scale, 1/4 is going to be an important note. So how do I turn my model to the size to 1/4 scale? And how do I turn these pieces to be 1/4 and actually 3D print it? So first, you select the object you want. So this is the 3D printed object I want. Yes, so I have it selected. And the first thing you do is type in the command scale. Not scale 1D, not scale 2D, scale. Once you have scale typed out, you press enter, and now it's going to tell you to select a base point. The base point doesn't entirely matter, so I typically just click a corner. And from here, do not click twice, because right now it's telling us at what scale do we want it at. It's telling us what is the scale factor. So we know that our scale is at 1/4 because in my hypothetical world, my professor told me to do it at 1/4. So how do I do that? So there is a little math involved. So what we have to know is 1/12. So 1 divided by 12 is 12 inches because we're trying to convert feet into inches. And 1/12 is that factor. So it's going to be 1/12 times your scale. So since our scale is 1/4, it is, let me get a calculator. Let me actually start writing this out. So text, let's just do this. So our scale is at 1/4 of an inch, and we need to turn our full scale model to model scale, I should say. To do that, we need 1/12, which is our turning feet to inches, and then we multiply that by 1/4. And from that, you would get 1/48. That is your scale factor. If in another hypothetical world he told us to do 1/16, instead of 1/4, it'd be 1/12 times 1/16. That would be our next scale factor, which is, if I remember correctly, it's 1/196, etc., etc. If he told us to do 1/8 of an inch, you don't have to do the inch mark. 1/8 of an inch, this would be 1/96, and the list goes on and on. That's 192. Sorry, that's the scale factor for 1/16th. And of course, you do 1/12. Let's base that 1/12 times 3/32. That can be a tricky one. Of course, you do this. You type the scale factor as 3 over. I'm brain fart. I can't do that math right now. 32 times 12. That'd be your bottom number, 384. 3/384. This would be your scale factor, and I don't think you have to. You don't have to find a common factor. I don't think that is a common factor divided by 3. Oh, so technically your scale would be 1/128 because if you reduce it, but you can just type this out if you don't need. You can just type it out entirely. You don't need to convert it down. But now that you know about scale factors, this is also a big one. If it's also the same scaling it down in AutoCAD. So if you import a model, it's in feet in AutoCAD, you can use the same method to actually make it smaller or bigger. If you do want to make something bigger, you don't do the 1/. You just type scale and just type in 128 to make it bigger by that much. I'll show you right here. Since we're in this hypothetical world, we're doing a fourth. We type in scale, we click a corner, and then we type out 1 over 48. That's what you should type out, and press enter. Oh, I put a freaking forward slash onto it. So 1 over 48. Press enter, and voila. We have now scaled it down. It's hard to zoom into this. And to scale it back up, I type in scale, I click corner. Instead of doing 1 divided, I just do 48. And it puts it back to the actual feet scale. But for now, we want it at model scale. So right now, this little lantern, this little light well, is at a 4th scale. So what we need to know next is we need to move this onto our millimeter file, our millimeter Rhino file. To do that, it's really, really simple. Just select what you want, Control C. You're going to copy it to the clipboard. And we literally just go over to the other Rhino file, Control V. It's going to be out in Narnia somewhere. See, it's selecting it over there. ZS to zoom selected. I can type in move, the move command, type a corner, and I want to move it all the way back to 0. So 0, enter. This is a very crucial and important step whenever you're 3D printing. So 3D printers really like reading in millimeters. If you ever buy a 3D printer, it's going to say 220 by 220 by 250 millimeters. That's the size of the bed itself. Of course, if you buy one of the new Bamboo printers, a Bamboo P1S, I'm just naming what I currently have in my vicinity. So Bamboo P1S, it's typically going to be a 256 by 256 by 256 millimeter bed. So let me, oh yeah, before we move on to actual what type of printer and how to actually print, that's essentially what you do to get started with printing is you just need to scale it down. In our case, for our models, since they're already scaled down, they're already in real model scale, we don't necessarily have to scale anything down. So in my case, if I just looked at this piece, Control C, and just move it over to the millimeter folder, that's not millimeter folder, just paste it in here, ZS to zoom into it, move it to the C plane. Oh yeah, before I got into the tangent, it's really crucial to move it to the C plane, your origin, because if this model is all the way over here, you're going to have issues whenever you export it out of the Rhino to print it. With the issues can be either some layers aren't adjusting properly, it's printing funny. Those are the issues that can be caused if your actual object is very far away from your C plane. This is the C plane if you don't remember. The little grid, that is your C plane. So always make sure it's at the C plane. Let me move this to Arctic. Let me take a drink of water. So we now have our 3D printable objects in our millimeter folder file. Now, how do we actually get this to a slicer? How do we actually get this, slice it, and then print it? So, as I told you before, during this during this step, it's important to know what your current bed size is um, for your printer. Let me look it up. Bamboo printer without the little comma in the end. So these printer itself, these are typically the best types of printers to actually get. Bamboo A1 Mini. I wouldn't really suggest this, but if you need a printer, this printer is probably the best bed slinger we call them on the market. I'm not sure in recent news, but that's the best bed slinger. I call them bed slingers because if you actually zoom into it, this bed goes forward and backwards, as compared to these models right here. These are called Core XY. The bed doesn't move. The only thing the bed does is go up and down, and this is what moves. So stability wise, these are better because the bed is not shaking the model. It's not moving it around. It won't have fails. But this is just talking 3D printer. They're all essentially the same. They're all different slicers. But you can see if I zoom in right here that you can barely read that. But from what I see, it says 256 by 256 by 256 millimeters. That is the size of your bed. That is your printable area. So what you can do is you can do the rectangle command, type in 256, enter, 256, and enter. So this is your bed. If you want to know the volume, you can just do the box command and do 256 3 times. You typically don't have to worry about, oops, you typically don't have to worry about the height. It's very rare to actually max out your printer unless you're printing so high that you have to accommodate for it, but normally you don't have to worry about the height overall. If your model is too high to be able to print. And as we can see, our little lantern right here is able to print. I typically just make sure that it's flat within the plane, because one thing you have to know is you got to make sure this bottom part is flat along with the bed, because if there's any angles that could have issues in the future in terms of sticking to the bed, because it's printing one thing and then it just gets launched inside the printer. So whenever you're printing, make sure it's flat. That's just one warning. So we know this object fits in here. Oh, well, maybe I can put my model in here. Well, looks like it fits. So I'm just gonna put it in here. Sneeze. All right. So we have our two objects. You can see that this is floating. I'll show you in a bit how to fix that within the slicer, because you can put supports. So one thing you got to make sure, you can see that these two aren't flush. So you're going to want to make sure that the two objects, or whatever, how many objects you have, are flush on the bottom with each other. To move that, I'm going to do the move command. Lock it, and then click this. Now they should be flush against each other. Or you just export these separately and then put them in the same file later on, which I'm going to do. So I'm going to select the object and then type in the command export. Similar to how you export in AutoCAD, it's the same way you export for your model to 3D print. But instead of, you're not changing it as an AutoCAD file, you're changing it as a STL. So you click Save Type As, don't change it from your Rhino model, your Rhino 8 3D model, and you put it as, you scroll down until you find STL, stereolithography, and STL. Of course, you name it to whatever you want. I'm just going to name it Lantern. This is all your preference. This is how you keep your stuff organized. I'm just going to move it to my desktop. And from here, oops, desktop. Oh, I wasn't clicking desktop, so I was clicking downloads. So now that I have selected my desktop and I'm ready to save, click save. From here, this window pops up. Make sure it's at 0.1 or 0.01. This is the quality of how you're printing. So you're going to see this is going to be hard to show up within the slicer, but typically the tolerance is what the quality is what the quality of the STL is going to show out. If you do if you increase this, in the end, this won't show up. It's just going to be flat in the end. So I typically like the highest quality, so I move it to 0.01. From here, Click OK. On the command line, you see it's successful. It saved it at this location on my desktop. And we do the same for this one. Click it, type in export. Make sure wherever you want to save it, I'm going to name this armature because this is what it is. Armature 0.01, click OK. So we've now just, did I export it as STL? Actually, didn't check. Yeah, it's an STL. So we have successfully just exported 2 STL files in Rhino. From here, if you've exported all your STL files, you're ready to print. For me, it shows up right here on my desktop since I put it on my desktop. And now, from this point on, it is very highly dependent on what 3D printer you have. I'll be showing you Bambulabs, the Bamboo Studio, with the printers the school has. Bamboo Studio. I'm going to open that up. It's opening up on my other monitor. Be patient a bit. Allow access. From here, this is what you're going to show up with. I'll minimize it a bit. And what you can do is either open this up and just drag one of these on here. It should open up a file for you. Right now it's not doing it. Or right here, just click. Oh, there you go. Just open up on a second monitor. You can either double click it, open it, and it should make a new file for you. Now you can see that it's in a 3D printable space. Here's my lantern. I successfully just moved my Rhino model, exported it, put it into millimeters, and now I'm able to 3D print it. You're gonna see right here, you're gonna see the little spike I was talking about. Now it's gonna be like a 3D printing issue if it's able to print that or not. That's something you worry about, but not something you don't really worry about. But we've successfully just changed Rhino into something physical using a 3D printer. For now, I'm just gonna be looking at the other settings. So how do you actually put another object in here? Well, I can click on this and move it around on the bed plate, or not or. I can just drag it over here and it just plops it in there. So any file, as long as it's STL, you can just move it around. And what's good about Bamboo and some other softwares don't have is that you can auto orient it. So it's going to choose the best placement where it's going to print so that it can save time because of course printing takes time and it's optimizing it to be the best. Like this is your time saver. Or you can auto orient it to have it organize all the pieces for you, but this is all like little stuff. So we have for 2 object, and of course from here, if let's say you wanted multiple beds, you can click here to add a plate, and you can just move this over here. Now they're in 2 separate plates. Well, from this one, you're gonna slice it. It's telling me on the information. This piece itself is gonna take 2 hours, but you're gonna see there's a warning. This warning is telling me that there's a cantilever, which is this piece right here. Like, how does the printer even support that? It's not. It's literally printing in the air. It's not going to support that. It's going to be under supports, enable support. I typically do tree, sometimes slim, but for now let's leave it on default. And slice plate. There we go. Now it's supporting it so that it doesn't fail. But for you guys, if you ever decide to 3D print this using the school's printer, if you do end up buying a 3D printer, make sure you do your own research on what printer you have. But if you're using any type of bamboo, you have to make sure you're using the specific printer itself. The schools, I'm telling you right now, have Bambulab X1 Carbon. This one I'm highlighting over right now. That's what the current school uses at the moment. It's going to give you a warning if you use a P1S, the one I have, onto a carbon. It's telling you like, well, hey, yo, you're using the wrong printer. Sometimes it doesn't tell you, which that can be very catastrophic as it can mess up the printers. So be aware. Make sure you select the right printer for, of course, the right printer for the right software, right? So if you're using a Carbon, make sure you put this to Carbon. If you're using your own printer, make sure you don't want to break your own printer. Make sure you're using the correct printer. Of course, there's plate type. So there's these different types of plates. If you're using the school's printer, so let me change the X1 Carbon. You're gonna notice that on the plate, if it's gold and it looks a little rough and scaly textured, that is a textured plate. But if it's smooth and it looks gray, that is typically a cool plate. That is the gray side. And if you read it, if you flip over the cool plate, it'll say the engineering plate. It typically says it right here. This bed plate looks almost exactly what it looks like, except for the grid and the color. So the name right here is going to tell you what type of things it sticks on. So there's different types of plastic and all that. I'm not going to get into it, but typically what you're printing normally is called PLA. That's all you need to know, that you're printing with PLA. You're going to see that the engineering plate is only able to use PETG, ABS, TPU, PA, and PC. You don't see PLA at all. So we're using the wrong plate. Make sure it's a cool plate. It's going to say specifically PLA only because that's the best plate to stick with. Sometimes it doesn't even work. Sometimes it doesn't even stick correctly. That's why it says glue stick can help. That's why there's a warning right there. So it's either a textured plate or a cool plate within the computer, within the school's, not computer, school's printer. And there you go. That is how you can export your Rhino and be able to 3D print into the school's computers or your personal computer. I can't show your own printers because I don't know what you use. If you decided, I would highly recommend getting Bamboos. They're the best in terms of speed and quality. But oh, Inception you saw right there. But that is all for me. I've shown you this week's stuff, and I hope I get to see all of you on Monday. Hope you're all safe, and well, I'll see you next week. Bye bye.